This is definitely the largest grouping of cybersecurity professionals that I've ever been in front of. I wanted to start by throwing out 3 words that I think always invoke a very emotional response when said. Sometimes that's a positive response, and sometimes that's a very negative response. And to go back in time a little bit, on May 5th of the year 2000, tens of millions of computers were infected with the I love you worm, and this worm overwrote computers, choked networks with tens of thousands of emails, and brought systems to a grinding halt. I suspect many of us in this room, if I'm showing my age, remember this. What was interesting about this was it was a time where I was working in a data center in California, and we had no idea what had hit us. We didn't have the context, we didn't have the visibility on our networks to really understand what was happening. And organizations, large and small at the time, had no other alternative but to really pull the plug on their systems. My name is Richard Dornhart, and I'm with Data3, and here with me on stage is Matt Berry from the CTO's office at VMware. Now, I suspect many of us in the room had to deal with the I love you worm. We were probably tasked with the challenge of cleaning it up. We know how difficult that was because of how it moved laterally through our networks. Now, this was a significant moment in my mind because it was a time when, as security professionals, we stopped and looked at the traditional controls that we were putting in place. Now, it certainly isn't the last time that we had to look at these traditional controls, and I believe that we're continuing to do that. And we've heard a lot today about the need to think differently. We need to look at what I like to say is our front door, and look at the locks that we're applying to our front door and the different controls. And really look at ways that we can deal with the complexity that I seem to be talking to customers about quite often with respect to managing all the different solutions and strategies that we're putting in place to solve some of these challenges. Now, right in the same time, as I was talking about I love you and the positive and the negative emotions, something very positive was happening. We had the introduction, or we saw the virtualization starting to go mainstream. Now, it's something that I think started off very slowly, but it gained significant momentum. And it's hard to find an organization today that almost hasn't 100% virtualized their infrastructure, and now we're moving out into the cloud. And this has allowed us to increase productivity and in dramatic fashion, and given us scale that we never thought that we would have. But I think as security professionals within we started to look at the world a little bit differently, and we had to deal with the securing virtual infrastructure. And we had to deal with a whole new problem, application sprawl. So as we know, it's as easy as a click of a button now to spin up an instance, whether it's in your own data center or in the cloud. And trying to apply our traditional security controls in traditional ways just doesn't suit anymore. And trying to, I guess, protect that front door. What we have is this challenge around massive urban sprawl. Essentially, we have more doors than we can deal with, and we're starting and leaving many doors unattended, which again causes us challenges when we're trying to stop the spread of malware or risks within our environment from a lateral perspective. So our increasing appetite to do more online, to have more online, more information. I heard a quote, connected devices is something like 50 billion devices, by the year 2020, means that almost everything we do now is online. And what really drove this point home for me was a couple of weeks ago, my wife asked me to manage the kids in the morning, which I don't typically do. And looking for the easy way out, being a good father, I thought, tuck shop or canteen, as they call it here. I thought, yeah, I'll just do that. So I went to the cupboard and I grabbed a brown paper bag and started writing sausage rolls and apples and things like that on the thing. And my youngest daughter looked at me and said, "Daddy, we don't. That's not how we do that. We use the computer. Mommy uses the computer to order Tuck Shop." And I thought to myself, man, if we're ordering Tuck Shop online, it's truly an amazing time to be alive. So, it's we're constantly hearing about, and we've heard a lot today about the different types of attacks. Whether it's another data theft, we hear about them almost on a daily basis. I sometimes use the word complacency. We're starting to accept that this is the norm. Credit card details or log-on credentials, etc. Earlier there was talk around cyber hack or cyber warfare and hacktivism and all these other things. And these are challenges, the real challenges that we're facing today on a daily basis. I suspect everybody in this room, in a matter of minutes, could go online, download a piece of malware, and then use that malware to attack an organization or an individual. And ransomware has shown just how simple that can be. So, I think we've dramatically improved on strategy. We've dramatically improved our technology. It's moved light years ahead. But I think what's interesting is when I was just thinking about this problem and thinking about the year 2000 and the way that I was solving some of my problems back then was telling people to pull plugs. And I don't condone this by any stretch of the imagination, but what I found is that in some respects I'm telling people that they need to do that again today. And I think that's just not an option in our connected world. It's definitely time for us to look at this problem differently. It's time for us to transform our security. And so, some of you may now be looking at this next slide and thinking to yourself, well, what does the skyline of San Francisco have to do with everything that I've just said? And Matt, maybe you can help articulate what that's all about.
Yeah, Richard, I think you were sort of alluding to this earlier. You're talking about urban sprawl and guarding the front doors.
Yep.
Well, I mean, if anything, our data centers are actually a lot like cities. The roads are a lot like the networks, the buildings are a lot like the servers, and our data centers are subject to some of the same problems that we see in cities. We get overcrowding, we get aging infrastructure, urban sprawl, it leads to congestion, and we have a whole range of new security issues to deal with in a large, busy city. In fact, if you look at the application itself, the application has fundamentally changed as well. Gone are the days when the application was this monolithic stack running on one server. You usually throw a firewall out in front of that server or that application. This is like putting a security guard at the front door of the building. It's pretty easy to vet who's coming and going. Today's applications, though, are vastly different. They're distributed. The network that runs between all of these components is now a critical part of that same application. In fact, speaking of the network, what we've ended up with, and to cope with this massive demand for new applications and new connectivity between these applications, we've ended up with this fairly flat network, a fairly open network inside the data center. And so when we look at security today, it's focused a lot on the perimeter. But what happens when that malware or that virus does get in? What happens when the overseas visitor comes through customs and they make it in with a virus? Same problem in a city. You have the propagation of this virus moving amongst the neighborhoods in that city. And we have the same problem in our data center today. There's very little control over that movement inside the data center. And to Richard's point, lateral movement is the issue. And there are the challenge really comes as to where do you put the controls to prevent that lateral movement, to prevent the application component to component movement of this malware. Do you try and put controls on every street corner? This is like putting 100 firewalls into the data center. What if you pick a boundary between zones, let's say a web zone and a database zone, where you have multiple applications running in that web zone, you have multiple databases running in the database zone. Suddenly you've got commingled applications in these zones running through a single firewall that now needs a horribly complex commingled firewall policy. And we have customers, I'm dealing with customers a lot, that have not just thousands, but tens of thousands of rules in these firewalls that sit between application boundaries. What if you tried to firewall all the way along the path and put multiple firewalls between the application components? What does the compound policy then look like between those application components? How do you know that you're getting the right level of firewalling or security between those application components without going into every single firewall and checking? And doing this ends up being expensive. You may need lots of firewalls to do this. So we at VMware, we make virtualization software. Now, some of you in this room probably don't even know that your applications, the ones that you manage, whether that being in your own data center or someone else's data center, those applications are made up of lots of small individual virtual machines. They're like a server, but they're now in software and can be moved around inside the data center. Virtualization actually presents this interesting property in that it's generally ubiquitous. It's run across multiple servers in your data centers or someone else's. It provides a consistent layer, if you like, a map between what the application needs and the underlying infrastructure. And in terms of security, virtualization actually presents three fairly useful properties. The first one is that because the application itself is running in that virtualized layer, you can actually align security controls very easily to that application. The second is, as I mentioned, it's ubiquitous. You can get the same level of control, the same ability to apply security controls across the entire environment. You're not at the mercy of features and functionality in the underlying infrastructure or in someone else's cloud. And finally, isolation. So rather than applying security controls in the operating system as an agent or embedded in the operating system in the same context as the application, and guess what? That application is the thing the attacker is firstly going to go after. Once they've got control of the application, they'll turn off those controls. They'll turn off the security controls inside that operating system. Virtualization gives you this layer outside of the boundary or the context of the application to apply security controls. And it's done fairly easily. You can take an existing environment with an existing virtualization layer, turn on capabilities around virtual networking and virtual security. So these are features that are available and can be turned on today. Spread that across the environment so you have that ubiquitous control. And actually deliver this layer in between the applications and your underlying infrastructure. So now the applications can be built with a topology that suits the application, independent of the underlying infrastructure. So as per the title of our session today, this is giving you the ability to fence off your neighbors, fence off the other applications that might be infected or that might be trying to pass malware into the applications that matter most to your business. Now, an application might be made up of multiple components. You might have a couple of virtual machines running, a database. You might have application VMs and web VMs and so on. But you can group those together now and easily attach a security policy to the entire application, regardless of where the components are actually positioned inside the data center. In fact, you can even go down further and apply security controls within the application zones, where these multiple web servers might exist. You don't want two web servers talking to each other. Why should they? They take incoming requests. They'll pass the request on to other tiers further down, but do those servers inside that web zone even need to talk to each other? So suddenly with this level of control, you really do get a transformational capability in the data center, the ability to actually go down and fence off some of these applications, and I guess put a blast radius around an attack. So the question I have for you is, rather than trying to secure your virtual environment, and as I said, a lot of you have heavy investment in virtualization today, you may not even know it, why not use virtualization to do that security, to provide those security controls? I've been Matt Berry, this is Richard Dornhart, thanks for your time.
Thank you.